So now we want to twist this thing. We started to look at the twist SOP before. I mean, it would be great. Maybe some future version of this will work. If I were to capture direction again in the y-axis, and it captured length as 28, meaning from bottom to top, as you can see, and then twist. It'd be awesome if it just twisted the volume for us, but it does not. So we need to create a custom deformer. The way that we would normally think of things in terms of deformation are we start with, let's say when we think about polygons, we start with all these points. The points exist in space, and then when something else comes along, like let's say this mountain, and it deforms it. So it goes from here to here. It pushed it from its original to its end location. Problem is, when we're dealing with voxels, we can't do it that way. If I started with a voxel of density here and I wanted to push it to somewhere else, I could do that, but then another voxel nearby it getting pushed in some other direction, there's just going to be a big gap in between them. And that doesn't happen with polygons because polygons exist everywhere between the points. So again, if I just move one of these, the polygon fills up whatever the space is between them. Does that make sense? Just by moving this one point, just by projecting one point out, it still interpolates back to his other point friends here. But with voxels, there is no notion of that. It's just a bunch of cells. So just by populating one cell out here now and populating one cell out here now, there isn't going to be, it's not going to get filled in all the places in between. I might, I'll put a little demo in here. So I thought I'd try to explain this issue a little bit more in a demo here. When we have a regular polygon pig, if we applied some kind of offset to these points to push them somewhere else, say with a soft transform, that's fine. We can do that because the points know who they're connected to, and we end up with this deformed mesh, but still, continuous looking thing. It still makes sense. If we were to start from a volume version of this, and we did the same transform, we get this, where the voxels break apart. They don't really have a notion of being connected to their buddies. So we end up with something like this. What it should look like is something more like this. Now, this is not an actual volume deformation down here. This was me just taking the new polygon mesh and turning it into a volume. That's fine but that's fine in this case because we had a solid pig head that we could do that. But back in the lesson, we've got a volume that is equal parts. It's empty, it's half density sometimes. It's all kinds of density values. It's not just on or off. It's an amorphous thing. I mean, that's why we're using a volume in the first place. So the point is, we can't convert that back into polygons, deform it, and then convert it back into volumes. We need to do an actual deformation on the volume itself. So, without getting into the details that we're about to do in the lesson itself, I would just say, generally speaking, we can't project forward like we do with the mesh. We need to look backwards, where for every voxel in this new space, we need to look back at the original volume representation to see how it should be filled out. So let's keep going. And hopefully we're back from that demo now. And hopefully that makes more sense than ever before. So what that is saying is we need to start from the new volume and look backwards into the original volume to find out what the new voxel should be. So to that end, let's do a volume wrangler. In this case, I'm just going to write over the old volume because I know I'm not actually going to be pushing the new densities out somewhere else, like out into this area out here. I know I'm just twisting things around itself. So all the voxels I already have here, I can probably reuse again for the new one. But for the next deformer we do, it's going to be a little bit more complicated. But let's live in the present. So this is going to be our twister. And this is a pretty fun idea. So what do we want to do? We want, in our new volume, so just imagine that this density has been cleared out in our new volume, because we're going to overwrite it here. In our new volume, we need to look up into the old volume somewhere. So if I were to just say, in my new volume, the density is equal to the old density times 2, well then, of course, it would just look like it has more density. So this has created basically our new volume, or it's replaced the old one with values that are twice as large as before. What if I did this? What if I said the density is equal to, let's use the volume sampler, because that's what we're going to use anyway. Let's look up somewhere else in the volume for a different value. So here, volume sample, let's volume sample our own volume, the incoming volume. Let's sample the density volume. And where are we going to sample it? Well, let's sample it where we are right now. So again, shouldn't really look too different. I mean, it looks different. It got more faded because we got rid of that 2 times density thing. But you can see with this off, it looked like this. With it on, it looks the same. Because at every voxel, we say the position of this voxel, look up what the voxel with the same position in the original volume is, which of course is the same. I mean, you know. I hope you're not screaming at your computer right now for taking too long, but I just want to make sure that we're all on the same page. Because now we're going to change it. What if we looked up our position plus something below us? So I'll say their current position minus 1 unit below us. It looks like this. So we've technically deformed our volume right now. Isn't that interesting? So our new density at any given space, let's look at these ones in the bottom here. Before, it looked like this. So when this wrangler runs, let's say right here, it says look up the value of the density at 1 unit below me, which is down here in nowhere's land. And that's why it's now nothing. All the voxels that were up here looked at one value below them, which is why it looks like things have moved up. And as you can imagine, that's just always going to work. We're just looking up in a different location in the volume something else. And that is the crux of what we're going to do. Where we're going to look at somewhere not below us, but we're going to look at somewhere that's in a different location rotated away from us around the center axis. So when we're starting off here, we're not going to look anywhere else because we're at the bottom. I want this rotation to accumulate, to increase as we get higher and higher. So when we're here, we're only going to look a little bit, let's say, to our left. Then by the time we get up here, we're going to look all the way over here. Then by the time we get up here, it's going to look a full maybe like 90 degrees swung around the side, and so on and so forth. And it's going to keep looking at a further, more and more rotation as we go higher and higher, and that's what's going to build our twist.